I'm pleased to be with you this afternoon and have the opportunity to introduce our guest speaker, Dan Gravel, who works with Vander Zalm and Associates, Inc. He will be discussing water spray parks and understanding your environment. Please join me in welcoming Mr. Gravel.
Thank you. Okay, water spray parks are a great attraction for kids, and it's also an emerging industry. Water spray parks are relatively new compared to other aquatic facilities, and the first spray park was built less than 30 years ago, and they are increasing very rapidly. Just to give you an idea of the size of the market in Canada alone, it's about $130 million annually. In the US, about $300 million. And globally, around the world, it's getting close to $1 billion annually and growing. There's more and more municipalities opting for building spray parks than traditional aquatic facilities because they are just a fraction of the cost of building a pool, and they can service more kids. The typical spray park can have hundreds of kids at a time using the spray park. Now, these spray parks come in many different sizes, configurations, and an unlimited options for spray features and the look and feel of the park. And the main point, well, for the kids anyway, from their perspective, the main purpose of a spray park is somewhere where kids can splash around and have fun. And that's what they really want. And as parents, we want a safe and fun environment for our kids to play in. And most parents, they think it's just water. It's easy, right? But as inspectors and designers, we know there's a lot more to water than that. Sometimes there's a lot more in the water than we really want to be. Now, there have been some outbreaks associated with water spray parks, and I just want to talk about a few of those here. Keep in mind, the first spray park was built in 1987 in BC. One of the first outbreaks recorded that was associated with a spray park was a park in Florida where approximately 4,800 people were exposed to gastroenteritis. Now keep in mind, these numbers they were exposed, not confirmed cases of people infected. In 2004, there was a park in Kelowna. There were 8 confirmed cases of people infected by E. coli. In 2005, this is the big one. In New York, Seneca Lake State Park, there was approximately 1,700 people exposed to crypto because of a sewer backup that infected the holding tank. And because of that outbreak, the state of New York issued a public health warning, and they were one of the first jurisdictions to create a spray park code. In 2007, there was an outbreak in Idaho with approximately 600 people exposed to crypto. And again, another park in Florida where there was another outbreak with crypto, and there were 3 confirmed cases there. Now, what do all of these parks have in common, besides what they were associated with spray parks? All of these cases, and every one that I'm aware of, they were all parks that were improperly maintained, improperly designed, or exposed to some external event, such as a sewer backup or a flood. To my knowledge, there's been no outbreak associated with a properly operating and maintained water spray park. But because of those those outbreaks, we realized that we need to change the way we're thinking about spray parks. Before 2005 and the New York outbreak, inspectors used a pool code because it was the closest thing we had to a spray park. But we quickly realized that those codes didn't work. They don't work for a spray park. A spray park, while it is an aquatic facility, it uses many of the same components. It doesn't work like a pool. It's a lot more complex in how it operates than a pool. But many jurisdictions started creating their own spray park codes because they realized these were different and they needed to be treated differently. And I myself have contributed to the development of some of these codes and other codes across North America. And the Model Aquatic Health Code is one of the first national spray park codes that was published, and that just came out just recently. Now, while we have these codes, one of the problems for the industry is every jurisdiction has a different code, different requirements, which is okay, but they vary greatly. Some jurisdictions don't have any codes at all for spray parks. And in those instances, they have to rely on the pool code, and that doesn't work. So we have these codes, and it provides us a good basis for moving on, but we need to change the way we're thinking about spray parks now in order to make them safer and a lot more fun in the future. But before we can design or create better spray park codes, we need to understand them. The first type of system, the most common, is the flow-through or potable system. This is probably 90% of all spray parks built around the world. This takes potable water. Let's try and use the cursor here. Potable water comes into the distribution manifold here, and then the water goes out through each of these lines to the spray park. Water splashes around, kids have fun, and the water collects in the drains, and it goes out into sanitary sewer. So that's the most common type of spray park. And inspectors are quite comfortable with this because it's all potable water, the water drains away, and there's no issues. The second type is a retain and reuse. This system is the same as a potable park, where we take potable water, it goes out to the spray park, and then the water that's collected in the drains goes into a holding tank, where we retain a portion of the water that's used, and that's repurposed for irrigation, flushing toilets, washing streets, various other purposes. And we can treat that water depending on what the requirements are for reusing it. And this one, health inspectors are generally comfortable with, just depending on what the purpose is of the water to be reused. Now these two parks, the flow through and the retain and reuse, these use a lot of water. The average size park can use 50,000 gallons a day. That's a lot of water and a lot of cost. There's many municipalities spending tens of thousands of dollars a year just on water. And because of the cost and our need to find more responsible uses for our water, we have the recirculation system. And this system takes a body of water in the holding tank, and then the recirculating water treatment system takes water from the holding tank, pushes it out to the park. The water is collected in the drains. It goes through a strainer system back into the holding tank, and it's just recirculated. It's that easy. Actually, it's not that easy. It's quite complex. In these recirculation systems, this is what makes health inspectors nervous. Because every park that has had an outbreak has been one that's had a recirculation system. And that's because the water is reused. So if there's some infectious bacteria or some type of contaminant, it gets into the system, and if not dealt with properly, it grows and becomes a problem. But these recirculation systems, these aren't the problem. We can deal with these and change how we're designing and thinking about these spray parks to help mitigate the risks associated with outbreaks. Now for the recirculation system, every one that's built is under two different types. You have the double loop right here and the single loop. Let's look at the double loop first. The double loop is called a double loop system because it has two circulation loops or systems. The first loop, which I'll call the filter loop, has a pump that takes water from the holding tank, pumps it through a sand filter, and then that goes back into the holding tank. And that recirculates continuously. That pump never shuts down. It runs 24/7 throughout the entire operating season. So that's the first loop of the double loop system. The second loop is the feature loop. And this has a pump that takes water from the holding tank. It sends it through a UV system where the water is irradiated. And then the water goes out through a distribution manifold where each line on the manifold goes to a specific feature on the play pad. So water goes out here, the kids play in it, and then it collects in a drain, and then it goes through a diverter and strainer, which is the first line of defense to protecting our water system. It has a strainer basket in there that strains out sticks, leaves, debris, toys, whatever kids throw down the drain, and prevents that from getting into our water system. And then the water goes into the holding tank, and it just keeps recirculating. We have automatic chemical control systems that automatically dose chemicals when needed and monitor the chemical levels, and controllers that make the system automatic, but not maintenance free. It still requires an operator once in a while to check on the system to make sure everything's operating properly. So that's a basic double loop system. The single loop is very similar. It uses the exact same components, except it only has one system loop. It only has one pump that takes water from the holding tank. It goes through the sand filter, then through the UV, through the manifold, and out to the park. So the one pump does everything. And this never shuts down for the entire season. This single loop system is often called 100% filtration and disinfection. And there are some jurisdictions that specify this type of system because every drop of water is filtered and treated and irradiated with UV before it goes out to the park. Where the double loop, there is the potential for untreated water to go out to the park. So many health officials prefer the single loop design. And it's also the newer design. This design, we just started doing this probably 6 years ago. Before that, the older double loop design was adopted from standard pool systems. But we're getting smarter about how we design and manage these systems. So that's basically how the water treatment system works. But now I want to talk about our environments. And this is where we really differ from a pool. Because in a pool, kids play, they're in the pool, that's their play environment, and that's also where the treatment happens, right? But in a spray park, it's different. We have our play environment. This is where the kids play. This is where they interact with water. But this is not where the treatment happens. We don't want the treatment happening here. In an ideal world, we don't want chlorine and acid out on our spraying on our kids. We don't want contaminants on our kids. We want perfectly pure, clean water out there. But unfortunately, we don't live in an ideal world. And so, beside our play environment, we have our treatment environment. The treatment environment is the holding tank. And these holding tanks, I put a lot of emphasis and effort into designing our holding tanks. And one of my purposes for this talk today is presenting these different environments so that we understand these systems better. These holding tanks are usually fiberglass or concrete, and typically between 2,000 and 4,000 US gallons in size, or larger depending on the size of the park. The important thing with the holding tank is that the larger body of water we have to work with, the better it is for the water chemistry. A smaller body of water is harder to balance the chemicals, is affected a lot more by any contaminants or anything in the water. So the more water we have, the better. There are very few codes that specify the size of the holding tank. California is one of the only jurisdictions, and BC, that specify the size for the holding tank. California requires a minimum of 4,000 US gallons, regardless of the size of the park. So the holding tank, this is where all the magic happens. And if you look inside, this is where things get really interesting and complex, because this is a very dynamic environment. To begin with, we have our water inlet to the holding tank. This is where water comes from the play pad. It's collected in the drains, and it comes into the tank at one end. And then the feature pump sucks water from the holding tank out of the opposite end. We want those at opposite ends. We have our filter pump suction at the same end as our feature pump, and the filter return at the same end as our drain water coming in from the pad. The reason we do that is that the filter water it's cleaner water, but it's also had the chemicals added to that line. So the chemicals come into the tank, the same location as the water from the pad. So as the water moves through the tank, we want a lot of agitation and mixing in here, so the water has plenty of time to interact and be treated by the chlorine. And we design these tanks so they have a minimum of 7 minutes retention time, which is something that very few companies do for these spray parks. We also have our freshwater fill connection so that whenever the water level drops in the tank, fresh potable water is added. And that replaces water that is lost due to evaporation, wind, kids wearing that off the pad. And eventually, the entire tank volume of water is replaced with new fresh water. We also have an overflow connection. So if the tank water level gets too high, that water goes out to a sewer. One thing that I always do, and again, we're the only ones that do this, and I would like to see this added to the codes, is that any drain or overflow connection has a backflow preventer in order to prevent a sewer backup. That is one of the biggest causes of outbreaks or contamination in a recirculating system. And putting a simple backflow preventer, it's a very inexpensive device on those overflow and drain connections, it's an easy solution. But we can also add baffles and other design elements into the tank, depending on the requirements or what we're trying to achieve in there. And this is an example of the design calculations that we do. And we designed for the volume of water in the tank, not the tank volume. A 4,000 US gallon tank, that's the capacity of the tank. But the water volume in there is only 3,800 gallons. So that changes your design calculations. We also design the retention time and the CT time values for proper log reduction for crypto and other viruses. I just want to show that that is how a proper system should be designed. Most companies don't do that because of cost. So those are the main components and the system for how a recirculating system works for spray parks. There's just a few more things I'd like to talk about. UV. A UV system is, I love UV. It's great, and it's one of our only or most effective options for treating crypto. UV systems, in my opinion, should be mandatory because they are a last line of defense against things like crypto. Not all UV systems are the same, and many spray park codes, there's only a few spray park codes that specify UV to be required. Some have it as a recommendation, and some don't specify UV at all. I would like to see UV specified, not only the type of UV system, the output parameters with proper 40 millijoules per centimeter squared of output at end of lamp life, and all the other parameters associated with a UV system for commercial aquatic systems, but also the placement. The UV system, the UV system should be placed directly before the water goes out to the park, because that's our last line. Any water that passes through the UV system is properly irradiated. The new Model Aquatic Health Code states that the UV system can go on the filter loop, which just runs, the water just goes back into the holding tank. But the feature loop, that's what sends water out to the park. That's where we want the UV system. So I would like to see UV added on the feature loop right before water goes out to the park. The next item is the water sampling and chemical addition. This is one area that I have, this is the most common area I have discussions with health inspectors on where this should be located. First of all, the sample, where you take the sample from, in my opinion, it should be taken right before, on the water, right before it goes out to the park, because that's what matters. That's what we're sending out to the kids. Some inspectors like to see what's happening in the holding tank, but I don't really care what's happening in there. The tank is a dynamic environment. It's going to do what's going to do. What we care about is the output. So that's why I like to see the sample taken from the water just before it goes out to the park. And chemical addition. Adding the chemicals into the filters loop on its way into the holding tank. That's important because that's where we need that magic to happen. We don't want to send rock, chlorine, and acid out to the park. And I have had some inspectors insist on doing that. So some of my recommendations for approving our spray park design. The first one is considering the water management strategy for the jurisdiction where the park is being built, and having this tied directly in with the plans and goals for that area and we can design the park appropriately to meet that. We need to understand the differences between a spray park and a pool. They're not the same. They use the same components. It is an aquatic facility, but it is a different animal. We need to understand that there's different environments with a spray park, and we need to design for those accordingly. The holding tank design is where a lot of the effort should be placed. And most codes and most people don't even think about they just want a holding tank just to hold the water. But the design and the function of the holding tank is critical to safe operation of a spray park. Again, I would like to see UV included as mandatory. It can't always. UV systems it's expensive. A typical UV system is $20,000 to $30,000 or more, depending on the size of the flow rate going through the park. So it is a big dollar item, and it's hard for municipalities to afford that. But my argument is, what's the cost of an outbreak, right? The water sampling location, having that on the feature loop right before it goes out to the spray park. And this is another one. This is the second most common cause of an outbreak. Improperly or not trained at all staff. This is an aquatic facility. For pools, they require certified pool operators or some other type of equivalent designation. The same should be required for spray parks. Improper operation and not understanding what this equipment is and how the system should operate causes a lot of problems. And probably the most calls we get for servicing spray parks is when somebody has done something and the system doesn't work anymore. So having certified pool operators, trained staff operating these parks is essential. And all of these items will greatly reduce the chance for outbreaks and problems that we've seen associated with spray parks. Spray parks are a great attraction for our kids. They provide a fun environment for them to play in, and by making some of these changes that I've talked about here today, we can all work together to make them a safer place for our kids to play.